All right, welcome. We're going to do a constant entropy turbine work process example. This is, for those of you in the NT170 class, this is going to be module 5 and practice problem number 5 on module 5. So what we have starting out is we're starting out with an 200 psi at 99.5% quality. So let's find that on our Mollier diagram first. So if I open up my Mollier diagram, I can see the constant pressure lines running this way. And you can see that the 200-pound line right here. And if we follow our percent moisture, we know that this red line here is 100% quality. And the problem gives us a 99.5% quality. So let's see what the increments are. And quality is, moisture content is 100 minus quality. So we know 100% quality. This is 0% moisture content. And then this is 99% quality because it's 1% moisture content. Can't draw. I had too much coffee this morning. So we know we're looking somewhere in between those two, in between this line and this line. So let's go back to our 200 point. We're looking for halfway between here and here. So this is the 99.5% quality line, or quality point when it crosses 200. So let's figure out what the enthalpy is of that point. To do that, we're going to follow these two enthalpy lines here and here, because it looks like we're right in the middle of both of those. So we're going to follow those two back over here to the left. And it looks like we're about 1,190 BTUs per pound mass. And if I erase this here so we can see exactly where we're at, we're probably closer to just above. So we're going to call it 1,196 BTUs per pound mass instead of 1,195. We're going to call it just a hair above that point. So we're going to, because we're trying to divide this line. Let's see, let's just erase all this. Because we're trying to divide this line and this line right in the middle on that 200 point line. So that's our starting point right there. Now, we have to figure out what we're doing. And what we're doing is a work turbine process. So a work turbine process is a constant entropy process. I'm just drawing an example line, which means that it's straight up and down. Whereas a throttling process, which is also one of the examples you had, is a constant enthalpy process. And those go left and right. So what we're going to do is we're going to find our exhaust pressure. Now our exhaust pressure, this Mollier diagram is all in PSIA. So I need to back out, go to the second page here. Let's take a look at our exhaust pressure. We're starting off with 23.82 inches mercury vacuum. Well, let's get rid of the vacuum. If you remember, we have two different scales for pressure. We have a relative and an absolute. And the absolute is you can't go any lower than that. And so we're talking about 23.82 inches of mercury vacuum, which means from a relative 0 of atmospheric. So if I had 0 inches mercury vacuum, this is 0 inches mercury vacuum right here, because that's atmospheric pressure. And then I have 23.82 inches of mercury vacuum. So I'm somewhere down here above 0. Because a perfect vacuum, 0 is equal to 29.92 inches of mercury. So all I have to do is subtract this 23.82 from the 29.92. And that gives me 6.1 inches of mercury. Absolute. So now I know I'm right here. I'm just somewhere above zero. I'm closer to the absolute zero. But we need to figure out what this is in PSIA. Well, in your steam tables on page 97, there's a chart here in the middle. And the way this works is if you take the thing you have in this left column, in this case, inches of mercury, and you multiply it by this conversion factor under whatever column you want to convert it to. So we have 6.1 inches of mercury, and we're going to go across to PSIA. And where it says PSIA, it says to multiply it by 0.49116. So if we multiply that by 0.49116, 6.1 times 0.49116, that gives us approximately, we're going to round it off, to 3 PSIA. All right? So we know we're exhausting to 3 PSIA. Let's go back to our Mollier diagram here, and let's find the 3 PSIA line. Well, it's right here, 3. So let's draw that out here, and then hopefully we got under the... Now, all you have to do is for a turbine work process, we're going straight down a constant entropy process, and we're just to the right of whatever this line is. So we're just going to stay just to the right of that line. I'm not going to draw this very straight. And we're just going to keep going straight down until we cross 3 PSIA. We just crossed 8, now 6, 5, 4, and 3. So this is where it crosses, let's change new color here, it's the 3 PSIA line. So now let's find out what our enthalpy is, our final enthalpy. So we just follow that there to the left, and we get to, looks like 915, 916, you know, wherever you land, however you see it. And it's tough to see on my iPad. When I did these problems, I had a big Mollier diagram so I could get down to the exact, which is why your example problem says 916. But if you have the 1195 minus 915, yeah, that works. That's on this scale. That's close enough. So 1195 minus 915. But this is the work. This red line here is the work process. This is what we're solving for. So 1195 BTUs per pound mass is our starting point, and 915 BTUs per pound mass is our end point, and you just subtract those. So we got 200, approximately 280 BTUs per pound mass. And that's how you solve number 5. All right. I hope that helps everybody. Thank you.